So we're now going to continue our discussion on graph transformations. In the last section, we talked about some basic rules for horizontal and vertical shifts, and also for reflections about the x and y axis. So we want to look here at a couple of additional examples. The first type of example asks us to write a function for the graph of the reciprocal function, shifted up 3 units and to the left 4 units. So the first thing that I need to think about is whether I know what the reciprocal function looks like. If you remember from the last section, when we talked about the library of important functions, we wrote down that the reciprocal function was the function f of x is equal to 1 over x. So you need to be sure that you know that. Now let's look at the transformations. So the first thing that we're told to do is to move the graph up 3 units. Remember, to transform a graph by shifting it either up or down means that you're either going to add or subtract a number to the end of the function. So if I want it to go up 3 units, I'm going to add 3 to the end of the function. Now we also want the graph to shift to the left 4 units. Remember that a left or right shift is a replacement, meaning you come to your function and in place of the x, you either put x plus a number or x minus a number. In this case, because we want it to shift to the left, we're going to do x plus the number. So we're going to do x plus 4. And remember that this is the one that's a little counterintuitive. If it shifts to the left, we're going to be adding instead of subtracting. So for our reciprocal function, we have 1 over x plus 4 plus 3. For our next example, we want a function of the graph of the absolute value function, shifted to the right 2 and reflected across the x-axis. So again, absolute value function, remembering that from your library of important functions, your absolute value function is the absolute value of x. Now the first shift that we want to do is to the right 2 units. So remember again, a left-right shift is a replacement. So we erase the x, and in its place we either put x plus a number or x minus a number. Since we want to shift to the right, we're going to do x minus, and our number would be 2. And then we also want to reflect across the x-axis. So remember, reflecting across the x-axis means that you're going to multiply your function by -1, which in this case is going to simply put a negative in front of my absolute value. And then our last example asks us to write a function for the graph of the square root function. We want to shift it down 2 units and reflect it across the y-axis. So our square root function, f of x is equal to the square root of x. Again, you want to be sure that you know that from your library of important functions. The first transformation is to move the graph down 2 units. So remember that to move up or down, we'll add or subtract a number on the end of the function. So since we want to go down 2, I'm going to do -2 on the end. And then the other transformation is we want to reflect across the y-axis. Remember, reflecting across the y-axis is a replacement of the x with a negative x. And so we now have our equation f of x is equal to the square root of -x minus 2.